do you know the difference between true and what are they? Something and something bearings. One's true and one's compass bearing. You know? I can
No.
whiteboard. Okay, so a true bearing is just when it's like taken from, like, say I had this and like this was my bearing. The true bearing would just be like 180 degrees kind of thing.
Yeah.
Wait, let me do that again. Not 180. Okay, maybe like I don't know, 160 degrees. So that's the true bearing when it's taken from north to wherever the line is. But a compass bearing is like when it's using the different never eat soggy wheat bix. So if the line's here, it would be taken between south and east. So it would be it'd be 20 degrees. It'd be south 20 degrees east, I'm pretty sure. Because it's taken, so it's 160 degrees this way, which means it's 20 degrees in here. Does that make sense? Because it's 180.
Yeah.
And so they're like the same, it's the same line or the same, what is it called? Same bearing, but they're just written different ways. So this would be 160 degrees true. And this would be south 20 degrees east. Does it make sense how it's, because it's like, it's south and then 20 degrees towards the east. Does that make sense? Kind of thing?
Yeah.
These ones are the harder ones, I find. Because
I don't like.
Yeah, go. What was it?
I don't like get what I'm meant to be doing. Like, am I meant to be figuring out the rest?
So in the first question, it says we have, what do we have? We have south 50 degrees west. So, and we have to say which of this equals a true bearing.
Okay.
First question. And so if we were to draw it, we know we're at south, so we know we're here, and we're going 50 degrees west. So if I put 50 degrees like here, 50 degrees west, does that make sense?
Yeah.
And so if we have to figure out what the true bearing of this would be, it'd be the 180 that it takes to get to south plus 50. Does that make sense?
Yeah.
And so 180 plus 50 equals 230. 230 degrees true. So it would be D for your first one.
So if I'm finding a true bearing, I just have to draw where the line is on the compass, and then from north, I have to see how much it is to get there.
Yeah. So that's a true, yep, from there to there, or it could be all the way around there. Like, yeah, so a true bearing is like just measuring a line from north, like that. But the compass is using, what are they called? Compass directions? Are they they're directions? Yes, they are. And it's like, it's always from north or south. So if I had a line here, it would be north 30 degrees east. And if I had a line here, it'd be north 50 degrees west. And then if I had a line here or whatever it would be, say that was 70 in there. Actually, no, it wouldn't be in there, it'd be in there. 70 degrees. So it's like measuring from north or south towards east or west. Does that make sense? Let me know if I need to explain it better. Do you want me to explain it?
It makes sense. It makes sense. I'm just like,
I'll do an example. Wait. Okay. Oh, we're still in the color red.
It makes sense. I'm just like, so if I got a question like that, would I have to draw the graph and like figure out the rest sort of thing?
Yeah, I feel like I would draw the graph of it, and I would say, well, this is what the compass bearing is, so what would the true bearing be?
Okay.
Go, yeah.
No, you go, because it's like in each like section sort of thing. Yeah, it doesn't matter.
What would the true bearing for this one be? Do you know?
Well, I don't know what like half of that compass is.
Like from here to here?
Yeah.
That's like 180.
Oh, because the whole thing equals 360?
Yeah, and each
Okay, that makes more sense.
is a
90 degree.
it's 90. Yeah.
Okay, no, that makes a lot of sense actually now.
Okay, cool. And so this true bearing would be
180 plus 40?
Yeah, so 220. But if there's ever I'll do it in a different color. Let's do it in green. If it was like this, the green line coming out here, and in here was 30 degrees, and they asked for like that true bearing, a true bearing always has to have 3 digits. And
okay.
You would write 030. It's
Okay.
stupid, but if you don't
Yeah, I feel like that's why I'm tripping up on it, because it's like really stupid.
Yeah. But if you don't put the 0, you won't get the mark for it. I've lost a mark before for not putting the 0, which is so annoying. But a true bearing always has 3 digits. So it's fine if it's like 220, because that has 3 digits anyway. But if it's like 90 or 80, just remember to put the 0 out the front.
Yeah.
Okay. Are you all good with those now?
Yeah.
Let me know if you aren't, because we can do some more questions if you want. But I think you've got the hang of it.
Yeah, no, I think I just needed to understand that.
Yeah. Cool. Okay. So you got 230, or D for question 1, was it?
Yeah.
Cool. For question 2?
Yes. Which formula should be used to calculate the distance between Emily and Holly?
I can get them up here.
Is the HSC like this?
Like the multiple choice questions kind of are.
Okay.
They're just like random bits of everything, the multiple choice ones.
Yeah.
But, yeah. Have you got an idea?
Okay, thinking it's C.
C. C would be for the area of the triangle. Let me share this for a second. Where's my thing? So say, because we're trying to find a formula that could calculate the distance between Emily and Holly, right?
Yeah.
And so if we know we've got to find this side between Emily and Holly, we've just got to figure out which one of these would work. And so if you were just trying to do it normally, what formula would you use? If you can just think off the top of your head. Like, what would be easiest?
The a squared plus b squared one.
Potentially, but for that one you need two sides. So you need to have an A side plus a B side, and we've only got one side. So if they had given us like 40 here, we could use it, but we only have one side given, so we can't use that one. And then we know, well, on your reference sheet, they'll give you, they give you all these formulas. And this one here, do you know, like if you're trying to find the area of a triangle, just normally, it's like half base times height.
Yeah.
And so this one here is also trying to find the area of a triangle, but it does, like when you do half base times height, that's with like a right angle triangle. And this one's the area of a triangle without a right angle. So that's why it's AB sine C. So we can't use that one either because it's the area of a triangle and not the distance between two things. And then B's just not even a formula. That's just there to trick you. And so the only one left would be A. Or you could, wait, where's my, oh, there's the erasers. Okay. Or if you were doing this question, you could do you remember putting arrows across?
Yeah.
And so then you'd have 20 over sine 80. What is going on? Sine 80 times x over sine 30. Do you remember doing that formula? Oh my goodness.
Yeah.
So that would give us what x would equal if we went then 20 sine. Oh my goodness, I must be clicking something. Okay. Oh my goodness, it's happening again. Okay, sine 80 times sine 30 would equal x. And so for that one, it would equal 2. So you could just look at it by eye and think, what would I do like to find x? I would do like the sine rule, which is the crossing and then doing that thing there. Or you could do it like by process of elimination. So you could go, what's this one here? Well, I need to have A and B. A and B are both sides. So I need to have two sides for it, but I only have one side. Does that make sense?
Yeah.
So I can't use that one. And then that one's area of a triangle. And then that's not even 1. So I can't use those 3. Does that make any sense? Any questions?
No, yeah, that was good.
Cool. And then the next one's nice because the area of the triangle, they gave us the formula in the above question. So it's pretty.
Yeah.
But it's also on your reference sheet, so it doesn't really matter.
What does A stand for?
At the front or the little a?
The little a.
I'll share it back up. So, wait, where are we here? Let me get the pen so I can write. Okay, so it's half AB sine C, yeah? Half AB sine C. And half is just 0.5, so that's fine, times A. And so if sine C, if they ever have like a sine, a cos, or a tan, that's always like the angle. Do you remember like SOHCAHTOA and using like the angles and stuff? Yeah. And so the angle would have to be this one here. So that would be sine C. And if this was C, the angle, then the one opposite would have to be C, the side.
Yeah.
And then one of these would be A or B. So that could be A or that could be. So it doesn't really matter. They could be the other way around. But so A and B, in all of those formulas up here, A and B always equal sides. And then sine A or sine B or cos C always equal the angle.
Okay.
And so then you just put it in your calculator. 0.5. Are you just writing it down?
I keep getting. Am I meant to do it separately?
Wait, what have you put in the calculator?
Like the whole equation.
Like, wait, can you see that? 0.5 times 39 times 47 times sine 21.
Oh, wait, I put cos.
Oh, no. All my things went away. That's fine.
You get 328?
Yeah, 328. Yeah.
Okay.
But yeah, the area of the triangle is sine. Maybe you saw this and accidentally put cos in instead of sine.
Oh, okay.
Does your area of the triangle say something different?
No.
Okay, good. Cool. Yeah, area of the triangle is always sine. All right.
This is so long.
Yeah, it looks very long.
Yeah, I know. Halfway through sending the photos, I was like, oh my gosh, this is so annoying.
Yeah, it looks, how many pages is it?
I don't even know.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. I do not like questions like number 4. I really hated them when I was doing them. Because it's 1 mark, but you do multiple steps to it.
Yeah. What does it mean, the bearing from C from A?
Up here, this part here. Bearing of C from A.
Yeah. I just didn't, does bearing just I just didn't know what it meant.
It's just the angle. So what's the angle of C from A?
Oh, okay.
If A is down here, and if you put what is it? What did we call those before? Compass things?
Yeah.
If a compass there at A, then the angle of C from A is just this one here, where the line.
Okay.
So it's 25 degrees, and then they put it up there for you as well.
Yeah.
And so we have to find the bearing of C from B. So where do you think the bearing of C, what would that be on the diagram?
Do you mean where C is?
Or what do we have to find? Because it says the bearing of C from B, but where is that on the diagram?
Well, if it's from B,
yeah. So it's
would
just
it be where A's one is, but on B? Does that make sense?
Yeah. So it'd be this thing here. Is that what you're seeing? That thing there?
Yeah.
Yeah. So that's what we have to find, and it's an angle. So I'm just going to put X there or something, maybe, just so we know that we have to find X there.
Okay.
And so do you have an idea of what the first step might be? Or are you still reading through it?
No, I finished reading through it. I just does it equal anything?
It will, but we just have to figure out how to find it, if that makes sense. It's
yeah.
So there's I don't know, they haven't given us very much, but you just have to what could we potentially, if we're just looking at this square, what would you normally do to find that angle there, X? Say this was 50 here.
Do you mean the compass things we did before?
Not really, but if you was just given this and they asked what X was, how would you figure it out?
I don't know.
Because a straight line equals 180 degrees.
Right.
So if you just did 180 minus 50, then X would equal 130. And so we just have to, if we use that same idea, if we use that in the question, if we can find what this angle here equals, then we minus 100.
Right.
We can figure out what X equals. Does that make sense?
Okay.
And so now, do you remember the formulas that we were looking at before? Where are they? These ones here. We can use some of those to figure out what theta equals.
Okay.
but we might have to like do it in different steps because we have 2 angles, but
would it be, I don't think, would it be D's formula? Because I don't think it would be.
no.
Would it be B's?
No, it would be, yeah, I think, wait. Yeah. So I don't actually think there is a way straight away to get theta.
Okay.
So you'd have to find another angle. So if we call this one y, and we can find y by doing this thing with the sine rule. And so go sine 25 over 18 equals sine y over 40. And then once we found what y equals, if we add y plus 25 and then minus whatever we get from 180, that will give us theta. It's really like, it's step by step. It's like really hard. I found this one tricky when I was doing it. I did it before, but yeah. So it's wait, are you all good following?
Yeah, no, I was just listening.
Okay. So it's like we figure out what we need to get. So we know we need to get theta here to then find what x equals. But we can't find theta based on the information we're given.
Right.
So instead of finding what theta is, we need to find something else to find what theta is to find what x equals. I don't know.
That's so annoying.
Yeah. So it's like we can't figure out what x equals, so we're going to use theta to figure out what x equals, but we don't know what theta equals, so we're going to find another angle to figure out what theta equals, to then figure out what x equals. Does that make sense?
Yes.
And so based on the information we've been given, we have to figure out what this angle here equals. And we can do that by the sine rule, which is the one where you cross them over.
Right.
And then, because the angle sum of a triangle equals 180. So once we found 2 angles, we can minus those 2 angles from 180, and that will give us theta. And then we minus theta from 180, and that will give us x.
Okay. Okay.
So the first thing to do would be to find angle C there.
Okay.
And so we can do the sine rule for that.
So opposite over hypotenuse?
No, the one that goes, not Sokotoa, but the one that goes like that.
Oh, right.
And because it's an angle, remember to do shift 1 or whatever it is.
When I press the sine?
Yeah. Just for sine C. Sine 25 doesn't have to have it, but.
So with the -1 thing?
Yeah.
How do I put an equal sign in my calculator?
I don't think, wait, like for this part here?
Yeah, no, like the equation up the top.
Oh, you'd have to take 40 over because you can't put an equal sign in the calculator. So if you take 40 over and that's divide, so you want to undo the divide, so you do the opposite. So you times. So then you put that into your calculator. Sine -1 and then that.
Okay. This is really hard.
Yeah. If this question was in like not multiple choice, it would be worth like 2 or 3 or 4 marks.
I got 69.9.
Yeah. So that's what C equals. So I'll write that down. C equals 69. And so I'm just going to erase that to give us more room.
Okay.
So we know what C equals. We know what C equals. And we know what A equals. And so if the angle sum of a triangle equals 180, and we need to figure out what theta is, we can do that by simply 180 minus 69.9. I don't know why I wrote 6 there. Is it 69.9? Yeah.
Yeah.
Minus 25. Does that make sense?
Yeah.
And then that will give us theta. So did you get 85.1?
Oh, yes, I haven't put it in yet. I was writing.
Oh, that's it. Sorry. Let me know when to stop so you can write it down.
No, yeah, that's fine. I did get 85.1.
Cool. So that's what our theta equals, which is here. Theta equals 85.1. And so, like before, if we had this and this, that equals 85.1 in there. And this whole thing has to equal 180.
Okay.
Then we just have to minus 85 from 180 again.
85.1 or just 85?
85.1, sorry.
I got 94.9, so was it
Yeah.
B?
Yeah, 94.9. And then if you press like the bubble button, do you remember what the bubble button is?
What bubble button?
Wait, I can't see what I'm showing you. I just call it the bubble button. I don't actually know what it's called. It's that one there.
Oh, yeah.
That will give you like 94.54, and then you know to round up.
Yeah.
But if you just look at it anyway, 94.9, you can round up anyway. So 95.
Yeah.
Oh no, on my things, every time I like stop my sharing, all the drawings disappear. And so
It's okay, I wrote it all down anyway.
So it's like looking at the diagram and it's thinking like, what do I like have? Like, what do I have? I have this side, and this angle. What do I need to find? Well, I need to find that there. So how can I like do different steps to get close to finding that? Does that make sense?
Yeah.
And so I think I have to do a couple of steps to get there, but I'll get there eventually. Okay.
Is it times then divide?
Yeah, yeah.
Okay.
Wait, what are you timesing, sorry?
Do I times 250 by 30 or 100?
Yeah, by 100. So it's liters times 100 over distance.
Okay. So then I times that, divide that answer by 30.
No, you divide it by 250. 250 kilometers, that's the distance. And then 30 liters is the liters.
Well, wait, so I times 250 by 100?
No, times 30 by 100.
Oh, right, okay.
30 by 100 divided by 250.
Yeah. Oh, so it's A.
Yeah, A. I think what you did last time was you divided, what was it? I think you did, like last lesson, 30 divided by 250, which gives you 0.12, and then you can times by 100, which is like the same as what the formula is. Like if the formula is this, that's what you did, 30 divided by 250 times 100. Does that make sense? Yeah.
Yeah.
Cool. Okay. All right. And we did one of these ones. Do you remember? It might even be the same one.
Yeah, maybe. Oh my god, it is the same one.
The exact same?
I think so. Oh no.
Did they just change a couple
Is
of...
it B?
Is it what?
Is it B?
I think it's C, I think.
What the hell?
Is it the same?
I think it, well, I have the same, like, numbers. Oh, wait, no, they changed it for some.
Yeah.
Oh, wait.
Did they?
No, they didn't. No, they didn't.
Let me see if I can find that one we did.
Yeah, no, I've got it right in front of me. Do you want me to show you?
Well, I think you said... here. Oh, it is the same. That's so funny. Oh no.
What?
I think it is B. When I did, because I did this question before, like 15 minutes before I went on to this lesson, but I did 6.6 as short distance when 6.6 is actually long distance. Silly me. Okay. So
wow, that's so good. We've already done it.
Yeah. Do you remember how we did it?
Yeah, no, I fully do.
Cool. So I think it would be B. Let me just quickly check. I don't want to. 495 over 100. 32. Lovely. All right, 7.
So is it B?
Yeah, B. Yep. Good job.
What's a scale factor?
So they would normally look like where's my drawing? Normally look like this, like how the question above. It's like a ratio. So if it's like if you're doing a map of like your town and you're saying like 100 centimeters equals 100 kilometers in real life, like this would be on the map and that would be real life. Does that make sense? Because you can't, like if you're drawing a map, you can't actually do 100 kilometers. So you like scale it down.
Okay.
A like reasonable amount, like 100 centimeters. And so it's just like two different things. And we just got to figure out what the scale is between the two. So here the scale was, I don't know, what is it, 1,000 or something? I don't know.
Is it C?
Yeah, 2, yeah. Because you can just write it out like 4 to 8, 3 to 6. How did they get from there to there times by 2? Yeah.
Yeah.
Perfect. Oh, networks.
Yeah.
Yeah.
By the way, I got A for the networks one.
Yes. Cool.
Okay.
Stop share.
And is it C?
10. Wow, are we up to 10? Is that what we're up to?
Yeah.
A bit. Says which is not a tree. D, did you say, or C?
C.
I think it is a tree. C. So a tree has like no cycles or no loops or
So is it B?
No, I think it's D. Because if you start at A, you can go there, 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 and you can come back to A. So like that's like a cycle. Whereas if you start here at A and you go to all the nodes, it's like you come back to A more than once, not just at the end. Does that make sense?
Right, yeah.
So like a cycle is when there's like nothing is repeated except the start and end one. Does that make sense?
Yeah, yeah.
So just picture like a tree, like when I was doing HSC, when I pictured a tree, I would literally just draw a tree with branches. And then I'd say which one, like, so like a tree with branches doesn't meet up together like this one does. Does that make sense? It just has like branches sticking out. Like, anyway, I don't know if that will help you or not, but I don't think you'll get a question. I don't know. You might, but I feel like you might not get a question like that. Okay. How many edges are in the graph?
8.
8?
Yeah.
Yeah, yeah. I wasn't sure if you said 8 or A.
Oh, sorry.
No, that's fine. But yes, B.
What are spanning trees?
Oh my goodness, what's going on with my thing? A spanning tree is just, okay, I can't remember what the actual definition is, but it's just like, how do I describe it? It's just, it's like, okay. It's where each of the nodes, or what do you call them, nodes or vertices?
Vertices.
Okay, where it's each of the vertices are connected with like the minimum number of lines.
Yeah.
Like this one to this one. So like that would be a spanning tree. So
Yeah.
all of the vertices are connected, but using the minimum number of edges.
Mm.
Does that make sense? So wait, let me see if I can find a definition for it.
Is it 12?
I feel like it might be. I didn't actually do this one because it would have taken a while to have a look.
Mm.
But there's definitely more than 3. I know that. And I doubt there's like more than 30. It could be 8 or it could be 12. I don't know. How did you get 12?
I counted how many branches are off for the vertices.
1, 2,
Edges.
I'm not actually sure with this one. Let me see if I can find networks. Let's see.
Oh, yeah. Minimum possible number of edges.
But is that a minimum spanning tree? I don't know if spanning trees and minimum spanning trees are different.
Oh, I don't know.
Yeah. A spanning tree is a tree that connects all of the vertices of a graph. I feel like, what's a minimum spanning tree? I think, oh, what does it say? Oh no. I don't think there is. Oh, so a minimum spanning tree is when there's weights on the edges, but a spanning tree is just without weights. So I feel like that is correct, but I don't know how to tell. Okay, I do know how to tell how many there are. It's just by drawing them all up. Does that make sense?
Yeah.
But I don't know if there's an easier way, because say there is 12, that's a lot. So like there's 1, 2, 3, 4, 5. So that's 1. What's another one? 1, 2, 3, 4, 5. Does that make sense? See, there's so many. Like that's already 3. There's definitely more than 3. So I don't know what to do for that one. Do you want to just draw them all up, or do you want me to do that, or do you want to come back to that, or I don't know.
Do you want to just like do it now?
Yeah. Do your friends have this? Right.
The same one?
Yeah. Does everybody get this one?
Yeah.
Oh, that's good. Okay.
Yeah, probably copy off them too, so it's fine.
Okay. I don't know how do we want to do this?
I'm drawing it in my book.
Okay. Wait, why am I doing that? I'm just going to do it here. Okay, let's see.
Oh, it's past 6. You don't have to do this if you don't want to.
No, it's fine. Let's do this one. Let's finish this page.
Are you sure? Because I really don't mind if you're like having dinner or like,
No,
I don't know. doing something.
After this, I'm going to watch another lecture, so I'd rather do this than watch a lecture. So I'm fine.
Why do you have to watch a lecture?
Because it's my uncle's wedding tomorrow. So I want to get like the uni work that I would.
Oh my gosh, yeah.
Yeah.
I remember. You told me.
There's literally so many.
Feel like we should just circle 30.
Just for fun. I wonder if there's a formula. Surely there's a formula to figure out.
Do I just like count how many ways each vertex can go?
Kind of. It's like just count all the ways that all the vertices are connected. I mean, but with the minimum number of edges. So like, for example, wait, what is it? I think I don't know. Like with this yellow one, all the vertices are connected, but not all the edges are used. Does that make sense?
Yeah. Do I always start from A?
No. So that's the thing. There's so many because you could start from wherever you want.
Oh my gosh.
There's no start vertice. Like if they had written start out the front of B, then you'd have to start at B, but they didn't. There's nothing there.
Well, that's rude.
I'm going to see if there's a formula. How to figure out how many spanning trees are possible in a network.
Do I just think of like how many possible ways?
Yeah.
Okay.
Oh, what the heck is this? One of my favorite ways of counting spanning trees is the contraction deletion theorem. What the heck? I don't understand this. Let me see if I can do it.
Maybe it's 8. Because I just counted 7 and I can't like.
Ooh. What? It says the number of spanning trees is n where the count of nodes. Huh? Wait. Let me see if I can. Oh, no. Okay. Okay. So how many nodes do we have? 1, 2, 3, 4, 5, 6. 6 to the power of 6 minus 2. Okay, that does not work.
Okay, I feel like it's 8 or 30. No, it's definitely not 30. Because it's not that big. And I just like got 7. And I feel like there's one more.
It does not make sense. This is saying this, n minus n to the power of 2. So that means it's 6 because there's 6 nodes, right?
Yeah.
6 to the power of 4 is 1,296. Which is stupid because that's not an answer.
Power of -4.
Let's try -4. No, -4 does not work. I don't know.
Should I just circle 8 and
Um,
then ask someone at school?
yeah. I can maybe just put an asterisk next to like 8 or 12 or whatever. Like, you know, it's definitely not 3.
Yeah.
And then maybe just see what they say, or I don't know.
I'll
Otherwise,
ask my teacher
yeah. You could ask them if there's a
and be
formula.
like, tell me the answer.
Because if there's a formula for it, that would be so good. But I've never come across a formula for it. So I don't know.
Yeah.
Do you want to do one more just so we're ahead?
Yeah, if you want to, I'm not forcing you.
Let's just do one more.
Okay.
I feel bad because I don't know the answer to the other one.
No, don't feel bad. Go and like sleep or something.
Okay, this one. Write the following measurements on the diagram. Okay, we can do that. It's worth 1 mark. Just to write them on the diagram. That's so good. I like that. Okay.
Okay, wait. What if I write it in the wrong place? Okay, where your mouse is 30, right?
Yeah.
Okay.
JK. And MK is 19. Okay.
Okay, what is the size of angle JMK to the nearest angle?
Oh, this is going to be...
Oh, no.
Okay, well, we know that this whole thing here is 75, yeah?
Yes.
Because alternate angles equal, yeah?
Yeah.
Okay. That still does not help us. Actually, we can figure out what this angle here, what x equals. Because that's a right angle, isn't it?
Yes.
So 90 minus 75.
Is it 105? Oh, wait. Whoops. 90. Sorry, I did 180.
15?
Yeah.
Cool. Okay. Then what?
What does it mean, like the size of it?
Like how big is that angle? How big is JMK? Like
Okay.
KLM, this one here, KLM.
Oh, what is the size of angle JMK?
Yeah. So JMK is this one, right? J to M to K. Is that little one?
Yeah.
Yeah.
Oh,
We
that's
don't
the
actually know
angle.
what that one is yet. I think I have an idea of what we can do though.
Okay.
Do you want me to tell you or do you want to have a look?
I mean, I'm probably not going to figure it out, but...
If you did you put the 15 up in the corner?
Yeah.
Yeah. So have a look at like the 15, the 30, the 19 as well. Oh, and this is what we want to find here. And do you remember our formulas? They're on your reference sheet. But so it's like
Yes.
whenever I get to a question like this and I get stuck, I just look at my formulas and I'm like, well, what can I do? Like, and I have a look at it. I can't do that one, can't do that one. I can do this one.
Do I have a formula sheet? I don't even have a formula sheet. Are you talking about question 2 again?
Well, they're the like B. B. What was B? Is that like C squared equals A plus B squared? That's like not a formula, but the other 3 are.
Okay.
And those 3 will be in your reference sheet. It's like it's the sheet they give you in the HSC full of information.
Is it C squared equals A squared plus B squared minus 2AB cos whatever? Because it's not the area one, and B isn't a formula, and A we used for the distance.
Well, you could use the C squared one, except that C squared, if you remember, C is a side.
Right.
And we want to try and find the angle X. So it might not, like it would work, but it wouldn't give us what we want. It would give us a side, not an angle. Does that make sense?
Yeah.
But what we can do, let me change the color. You can do this one again. Because we have a side and an angle to match, and then we have a side, and then we can find that angle. Does that make sense?
Yes.
So if we have sine X over 30 equals sine 15 over 19. And then can you see if it's in lime green or is that hurting your eyes?
Yeah.
Okay, good. So the first step would be to like put in what you know. So they gave us these things up here. So you fill in those things. And then we found out what this angle here was, 15.
Yeah.
And then we figured it out. Yeah. And then that would give us, oh, and remember to do shift sign.
Do you get 24.12?
Yeah. So 24 degrees.
Okay.
Are you all good with how we got to the lime green part?
Yeah.
Okay, cool. So essentially just put in everything you know and then put in everything that you could find out and then just look at your formulas and be like, I can use this one and let's do that.
Yeah.
Make sense?
Yeah.
Cool.